Yeah, guys, one more minute, then we'll start. We are waiting for others to join also. Okay. Hello, good evening, Ganesh. Yeah, good evening, everyone. So today is the last lecture for Quadratics, and as I told you in the previous lecture, we will be doing some questions, and many of the questions are from previous year JEE mains. And last we will do some questions from JEE 2021 also, which we did not covered in your weekend classes. Correct? So yeah, guys, let's get started without delaying. We'll start with some questions directly. I hope you will give some answers. Okay. So yeah, welcome back everyone. Let's start. So the first one is this. Let's read the question together. Alpha quadratic equation x square minus x plus 3 equals to 0. Now see, these types of questions are very famous, guys. That means higher power questions. What is meant by higher power? Higher power means there will be a quadratic equation given and there will be some higher powers of the roots, such as here. Here, as you can see, we want alpha raised to the power 4 plus beta raised to the power 4. Now, please understand, according to the question, we have two methods to solve. We will discuss both the methods. One of the method is that if the power is adjustable, then we use algebraic identities such as cube and so on to adjust the powers. But if the powers are very huge, sometimes we get alpha raised to the power 96 plus beta raised to the power 96. Those of you who have attended the lecture on the weekend must know we discussed this. So alpha raised to the power 80 plus beta raised to the power 80. So when such huge powers come, we avoid algebraic identities. We do it with second method, which we'll discuss today as well. So yeah, here the powers are very less, so it is better to use algebraic identities. Now, two relations I already know in the roots, that is sum of the roots and product of the roots. What is the sum of the roots? Is minus b by a, and product of the roots c by a, right? If we compare this equation with ax square plus bx plus c equals to 0. Correct, guys? Ganesh, are you? Yes or no? You can give me thumbs up, Ganesh. Are you understanding, Ganesh? And Santosh. Santosh, I saw you after a very long time. Ganesh. Okay. Chalo. So here we can get power 4 by using. First we'll use alpha plus beta, the whole square. What is it? It is alpha square plus beta square plus 2 alpha beta. You know the values. What is alpha plus beta? It is 1. Let us substitute these values here. So we'll get 1 is equals to alpha square plus beta square plus alpha beta is 3. So 6. So from here we got alpha square plus beta square is equals to minus 5. Now we want power 4. So what do? We square on both the sides. So alpha square, okay, we can square it here itself. If we square on both the sides, what we'll get? Alpha raised to the power 4 plus beta raised to the power 4 plus 2 alpha beta the whole square equals to 25. So from here we get alpha raised to the power 4 plus beta raised to the power 4 plus alpha beta is 3. This is 3 square, which is 9 to 25. So simply, very easily, we get alpha raised to the power 4 plus beta raised to the power 4 as 7. So it's option number D. What is the option? It's option D. Correct, guys? Let's move to the next question, which is this one. Again, I told you we'll be doing two methods. One method that I just showed you by using algebraic identities. The other method, which you can see here, we'll be using this. Now, before that, do you all have any idea how to solve these equations? If yes, you can please give me some hint or help me to solve this equation. Come on, let's see. I'll give you 1 minute to think about the equation and to solve. Please, guys, make the question as interactive as possible. Santosh, I can't hear you. Are you there? Give me a thumbs up. Hello, Santosh. Okay, chalo. I'll give you 1 minute to try to figure out what to do, and then we'll start. Chalo, guys. Let's see. Come on, guys. Are you there? Did you do something? Did you think of it? Chalo. I think I've given you enough time. So let's get started. See, here the second method is we substitute the roots in the equation itself and we simplify it with higher powers. What I'm saying is alpha and beta are the roots of this quadratic equation. Then alpha and beta must satisfy. So if I take alpha, then I'll get alpha square minus 2 alpha plus 4 equals to 0. Now, what do I want, guys? I want alpha raised to the power 5. So that means we need to square the equation, this one, but we'll not directly square it. We'll do something like this. Alpha square plus 4 is equals to 2 alpha. And now we'll square it. So after squaring, what do we got, guys? We got a square plus 2ab plus b square. So a square plus 8 alpha square plus 16 is equals to 4 alpha square. Now we can get the value of from here. What is the value of alpha square? Substitute it here. This reducing. This is known as reducing the power. So that means basically simplifying. Plus 8 alpha square plus 16 is equal to 4 into what is alpha square? It is 2 alpha minus 4. That means this is 8 2 alpha. Did we made a mistake? A square plus 16. Okay, so alpha square. Okay. See, this 8 alpha. Now again it's become simpler. So I think now it's proper. So we can simplify the equation. After that, we'll substitute the value 4 alpha square plus 16 equals to 0. Now we can substitute right here. So we'll get alpha raised to the power 4 plus what is alpha square? 2 alpha minus 4 plus 16 equals to 0. So what do we have here? We'll have alpha raised to the power 4 plus 8 alpha minus 16 plus 16 equals to 0. See how easily this got cancelled, and we got alpha raised to the power 4 plus 8 alpha is equals to 0. Now remember, we want the power 5. So if we multiply by alpha, then we'll get alpha raised to the power 5 plus 8 alpha square equals to 0. Now again, substitute alpha square. What is alpha square? Alpha raised to the power 5 plus 8 into alpha square is 2 alpha minus 4 equals to 0. So finally, what do we have here, guys? We have alpha to the power 5 plus 16 alpha minus 32 equals to 0. Now the same process if we do with beta. So what do we will get? Beta raised to the power 5 plus 16 beta minus 32 equals to 0. Now please see here. What do we want, guys? We want alpha raised to the power 5 plus beta raised to the power 5. So what do add them? If we add them, then we'll get alpha raised to the power 5 plus beta raised to the power 5. Here we can take 16 common, we'll get alpha plus beta. Here we'll get minus 64 equals to 0. Right, guys? Come on, let's see. Now, alpha plus beta. What is alpha plus beta? Sum of the roots is minus b by a, right? This is a quadratic equation. Sum of the roots is 2. Just substitute the value. So we'll get alpha power 5 plus beta power 5 plus 32 minus 64 equals to 0. That means alpha power 5 plus beta power 5 equals to 32. This is my answer. 32. That means option number 2. Second option is my answer. I hope it is clear, guys. Is it clear? Both of you, Ganesh, give me a thumbs up if it's clear, guys. Okay, super. Thank you, Santosh. Let's see the next one. Yeah, let's see. I'll give you some time to think about it. What do you think? Come on, let me know. Okay, guys? I'm giving you some time. This is very simple. Again, a nice question. Come on, let's see. What do you guys can think? Okay, I'm giving you some time. Let's see. I'm giving you only 2 minutes, guys. Fast. Take a pen and a book and start solving. Come on, guys. Are you ready? See, here again, the same thing. If alpha and beta, we'll have 3 alpha square plus 5 alpha equals to 7. If you notice carefully, we want 3 alpha plus 5. So if I take alpha common, I'll get my required, which is, what will I get? 3 alpha plus 5 equals to 7. So what is 3 alpha plus 5? 3 alpha plus 5 is 7 upon alpha. Similarly, 3 beta plus 5 is will be 7 upon beta. Let's substitute both of them here. So that means what will I get, guys? What will I get? Come on. We want the square. So we'll get 1 upon 7 square is. Similarly, beta square upon 49. Now, how to get alpha square plus beta square? This is basically equals to alpha square plus beta square upon 49. What is alpha square plus beta square? If you don't know, you can directly write it, or if you know, you can directly write it. If you don't know, see question number 1. How do we got alpha square plus beta square? It was alpha plus beta, the whole square minus 2 alpha beta upon 49. Now, from here, what is alpha? Is minus b by a, and product of the roots. What is alpha beta? It is c by a. Correct. So what do we have here now? Alpha plus beta, the whole square. So we'll get 25 by 9 minus plus 14 by 3 upon 49. We need to take LCM. So for taking LCM, what do we do here? We multiply and divide by 3. So the LCM is 9. So what do we have here, guys? We'll have 25 plus 43, which is 42 upon 9 into 49. So I think 9 into 49. What is it? 441, I guess. Yeah. So this will be 67 upon 9 nines are 81. Okay, 441 is my answer. 67 upon 441, which is option number. Do you all get it, guys? Ganesh and Santosh. Yes or no, guys? Give me a thumbs up. Ganesh and Santosh. Are you there, everyone? Ganesh, Santosh. Is it clear or should I explain it again? Hello, Santosh. Hello. Are you there, Santosh? Santosh. Ganesh. Hello. Can you hear me? Come on, guys. I think you just. Santosh has some network issues. Okay, Santosh. Noted. What about Ganesh? Ganesh. Ganesh, you are attending from the tab room, I think, right? I don't think you must have a network issue. I can't hear you, Ganesh. Can you type in the chat box? Ganesh. Can you type in the chat box? Let's see the next one. Please, guys, are you there or not? Where is Ganesh? Can you type Ganesh? Nothing is visible. Why? Santosh, can you see my screen? Can you hear my voice? Santosh, give me a thumbs up. Okay. Ganesh, please check your network. Poor network. Guys, please make sure that you sit in good network area. I think Ganesh has joined from your tab, right? The tab room. So then why is the Wi-Fi not working? Is the Wi-Fi working or not? Ganesh. All are using. So why are they not attending the lecture? Only you are attending? Where are the others? Bio students. Okay, so fine. ठीक है. So we'll continue. See the question here. What is the question here? If the roots of the equation are real in magnitude but opposite in sign. Excuse me. So it's a quadratic equation. I know it doesn't look like it, but if we take LCM, it looks like a quadratic equation. So let's write the equation here after simplifying. If we take LCM, what will we'll have? We'll have x plus p plus x plus q upon x plus p into x plus q is equals to 1 up. That means we'll get r into 2x plus p plus q is equals to 1 into x plus p into x plus r, which is x squared plus p plus q x. So if we simplify it, we get 2rx plus r into p plus q is equals to x squared plus p plus q x plus p. Now simplifying the quadratic equation further, that means we will take everything on one side. So what do we have here? We'll have x squared plus p plus q minus 2r into x plus pq minus r into p plus q equals to 0. Now, they have given, what have they given? That the roots are equal in magnitude but opposite in sign. That means alpha is minus beta. So what is alpha plus beta? It is 0. Alpha plus beta is sum of the roots. Here, sum of the roots minus b by a. Minus b by a. So 2r minus p minus q equals to 0. So we got 2r is equals to p plus q. Let's mark it as equation number 1. Next, the product. What is the product of the roots? Alpha beta. Product of the roots is c by a. That is, C is PQ minus R into P plus Q, right? So PQ minus R into P plus Q by A. A is 1. So now what is R? We can substitute R here. What do we want the equation in terms of P and Q? R here. Let us substitute here. What we'll get? PQ minus P plus Q by 2 into P plus Q. So if we take LCM, I think I get 2PQ minus P square plus 2PQ plus Q square, which is P plus Q the whole square upon 2. So what do we have here, guys? We'll have minus times common. This P2PQ, this 2PQ will get cancelled. As when we'll open the bracket, minus will go inside. So P square plus Q square by 2. This is my answer. Minus P square plus Q square by 2, which is option number 3. Let's see the next. If A plus B plus C equals to 0, the equation has imaginary roots, real roots. That means how to get real roots or imaginary roots or anything like that. What do we do, guys? What do? We find discriminant. Excuse me. We find discriminant. Let us find discriminant here. What is discriminant? B square minus 4 into A into C equals to 0. 4 and 4 we get cancelled. So we get B square minus 3AC equals, sorry, not equals to 0. Why am I writing equals to 0? We don't know what it is, right? So let's see, A plus B plus C equals to 0. So I can write B ki jagah pe minus A minus C. But since it's square, A plus C the whole square, the minus sign will get squared. So it is A square plus 2AC plus C square minus 3AC. So what do we have here? A square plus AC plus C square. Sorry, minus AC. Now, how to get its sign? How to get its sign? I can write as A square plus C square minus AC. Correct? Did we made a mistake here, guys? B square minus 4 AC. So B 2 4B square minus 4. Oh, I think we cannot cancel 4, right? Because it's not equal. So basically we can take 4 common. So nothing will change. 4 and 4. Now we can make a perfect square. How to make a perfect square? A square plus C square minus 2AC plus AC. So this is a perfect square, which I can write it as A minus C the whole square plus AC. Correct? So now see here, guys, this quantity is 4A minus C the whole square, which is always positive, as it's a square. And from that, something is getting added. So if square quantity में कुछ add हो रहा है, then it is obviously positive. That means it is greater than 0. It will not be equal to 0. That means option number 3. It has real and different roots. I hope it is clear. Let's move to the next question. If the roots of the equation, what does it say? If the roots of the equation are simultaneously real, what does this mean? That means both the roots of the equations are real. That means in both the equations, the discriminant is, excuse me, greater than and equal to 0. So let's look at this equation. So discriminant will be b square minus 4ac equals to, sorry, greater than or equals to 0. So q square, if we square on both the sides, what will it, sorry, if we take, cancel out 4, so q square is greater than equals to pr. Next, let's look at this equation. So I'll get discriminant equals to b square 4pr minus 4q square is greater than or equals to 0. Answered, and I get pr is greater than q square, or you can write q square less than equals to pr. Now look at these two equations, guys. And means intersection. What is the intersection? That means q square is equals to pr. And if q square equals to pr, that means our option is option number 3. I hope it is clear. Please guys, make yourself very clear here. Is now everything proper? Santosh and Ganesh? Santosh and Ganesh, are you able to hear me and see? Are your screen now visible? My screen. Okay, Santosh. What about Ganesh? Are bio students still there? Or did you came out of the room? Yes, Ganesh. What is your opinion? Hello, Ganesh. Is your network okay now? You can type in the chat box, Ganesh. Okay, superb, Ganesh. Let's see the next question then. Now, this is a very interesting question and one of a good question. So it is given that the quadratic equation is a perfect square. What does that mean? If a quadratic equation is a perfect square, that means its discriminant is equals to 0. So here, let's find discriminant. It's b square minus 4ac. So a minus b, b minus c is equals to 0. So what do we have here? If you open the bracket, I'll get a square minus 2ac plus c square minus 4ac into ab minus ac minus b square plus bc equals to 0. AB minus AC minus B square. Let us open the bracket. So we get A square B square minus 2AB square C plus B square C square minus 4A square BC plus 2 plus 4A square C square plus 4ab square c minus 4abc square equals to 0. Correct. Now let's see what we have here. Are there some like terms? ab square c, ab square c. Okay, okay. So we can write a square b square plus 6, sorry, plus b square c square plus 2a b square c. Oh, no common terms. 4a square bc plus 4c square a square minus 4abc square equals to 0. So what do we have here, guys? Can we take something common? Come on. If we group some of the terms, we can take something common. So for example, let's see these two terms. 4a square bc and 4abc square. And again this term. So we can take abc common, correct? So if I try to take 2abc common, so what will we have? I think there is some issue in the question. Because the coefficients are also not corresponding, and did we made a issue somewhere? So b square into c minus a the whole square. So b square minus 4, a minus b minus c. Plus bc. I think, okay. I'll check this question again and let you all know. For now, let us not waste our time doing it. Okay. Can we take something common and see? No. There's nothing common. For ABC. So here will be left with B plus 2A plus 2C. B minus 2A plus 2C. So B minus 2A plus, okay, never mind. I'll let you know this question. Yeah, let's solve this. What does the equation say? If x square plus ax plus b and x square plus ax plus b and x square plus bx plus a have a common root. Now, if both of them have a common root, what does that mean? Let alpha be the common root. That means alpha should satisfy this, alpha should satisfy this. So we'll get alpha square plus a alpha plus b equals to 0 and alpha square plus b alpha on, we'll get alpha into a minus b to a minus b. We can cancel out and we will get simply the value of alpha is 1. Now, 1 substituted here. So 1 plus alpha plus alpha का value 1 है. So 1 plus a plus b equals to 0. So a plus b is minus 1. So my correct option is option number 4. Let's see the next. Yeah. These are the PYQs from JEE 2021. Let's quickly look at them. So here we have the number of real solutions. It's a very cool question. We just have to use mod. We can write the equation as mod x the whole square minus mod x minus 12 equals to 0. Mod x minus 4 into mod x plus 3 are the factors equal to 0. So here we have mod x equals to 4 or mod x equals to minus. This is not possible because modulus of a real number cannot be negative. So that means x is plus or minus 2. Number of real solutions is 2. See guys, very simple. Asked in JEE mains. Let's look at the next one. Next is quite interesting example. Here I would suggest you to put e raised to x as t. So we get t raised to 4 minus t cube minus 4t square minus t plus 1 equals to 0. This looks like a quadratic. But if it divide throughout by t square, so we'll get t square minus t minus 4 minus 1 by t plus 1 by t square equals to 0. Now we'll group them together. T square plus 1 by t square, we'll group it, first and last term, minus t plus 1 by t, we'll group this, minus 4 equals to, here guys, t plus 1 by t. So t square plus 1 by t square can be written as t plus 1 by t, the whole square minus 2 minus t plus 1 by t minus 4 equals to 0. So let t plus 1 by t be x. So this is x square minus 2 minus x square minus 2 minus x minus 4 equals to 0. What do we have here? X square minus x minus 6 equals to 0. What are the factors? So x is equals to minus 3 or x is equals to plus 2. What is x? T plus 1 by t is equals to 3. या फिर t plus 1 by t is equals to minus 2. Let's take LCM. So I'll get t square minus 3t plus 1 equals to 0. Here I'll get t square plus 2t plus 1 equals to 0. What is this? T plus 1 the whole square. That means t plus 1 the whole square equals to 0. That means t is minus 1. What is t? What is t? Let me write it here. T was e raised to x. So e raised to x is minus 1. Not possible because anything in power cannot be negative. Let's solve it here. Here we went to find discriminant. So b square minus 4ac upon 2a. So I think we need to use the formula method. So let's try to use the formula method here. If we use the formula method, I think this space will be enough. T is minus b plus minus under root of b square minus 4ac upon 2a. Is 3 plus or minus root 5 by 2. That means 3 plus root 5 is something around 2 point. Root 5 is something around 2 point something. So 3 minus 2, both are positive. Great, great. Simple guys. So we got 2 roots from here. And both roots are positive. Both roots are positive. And if both roots are positive, then there exists a value of x. That means the number of roots of the equation is 2. This is our final answer. How many roots are there? 2 roots. How many roots are there? 2 roots. Correct, guys? So thank you all for joining and waiting for some extra time because of the lecture. The lecture is over. All the best, guys. From the next time, we'll be starting with, I think, trigonometry, or sorry, complex numbers. So let's see what we have. Until then, bye bye everyone, guys. Take care. Thank you.